Hello. Let me get that webcam on. Hey, what's up? How are we doing? Anybody here? Am I all alone? Yeah. Awesome, that's somebody at least, right? Yo. Awesome. What's up? So, a couple of notes. I enabled NVIDIA Broadcaster on the microphones. You don't have to listen to me sip tea. Yeah, and I also started uploading to YouTube. So I just started that from the last stream. So if you type -social in the chat, you get a link to the Twitter and the YouTube. And I will upload every stream from now on afterwards to that platform, so you can watch it. That's also why I wanted to improve the sound quality and stuff, because if you're gonna watch it afterwards on YouTube, it should be decent. So we did lose like the 3 first streams because I wasn't aware that Twitch deleted it. I thought Twitch had it for like 60 days or something. They only have it for a couple of weeks. So the first couple of streams, 2 or 3, we actually lost permanently. I haven't been able to recover those. I tried different techniques and stuff, but I was only able to recover like the 2 last streams I did, which is sad. But I mean, yeah, the streams do improve every time I do them. So I mean, I'm not saying that they were decent, but hopefully we'll make more content and I'll make up for it. Sadly, yeah. And I can't recall who told me, but somebody told me pretty early on when I started streaming that you should upload to YouTube. And I was like, nah, it's okay. Twitch will save me, but Twitch screwed me. So sadly, that's how that is. Awesome. So today we will be, so last stream we looked at sort of a cheeky way to just deploy POSH2 stagers onto a machine by patching AMSI both in PowerShell, or both were in PowerShell, but one method patched PowerShell's or system management automation's integration with the native AMSI DLL, and the other method patched the actual native AMSI DLL. Which would allow us to not only run PowerShell scripts without getting caught, but also load C# binaries into memory without getting caught by Defender. And that's all nice and well, but if you have to drop on disk, or if you typically want to have the actual files on scan time, if you want to call it that, without signatures. So when you drop it on disk, or you move it from memory stick onto disk or whatever, you don't get caught out straight up. So I'm probably going to refer to like scan time detection, which would be signature detections upon touching disk, and then I'm going to talk about runtime detections, which is detections that occur when you do specific actions. So it's really easy to say patch Mimikatz to get around scan time detection, but a lot of the stuff, the noise that Mimikatz generates when they deploy on the target is going to trigger runtime detections, and you're going to get killed when you do something. So that's something to keep in mind. So let me switch over to the VM view here. So I have Windows Attacker Machine again with my trusty boss David in the background here. Ooh, Rasta is in the chat. Hello. David is here, and then obviously I got my Linux VM, which from the last stream we set up POSH. So if I do POSH config-l. Oops, oh no, I'm in Vim, guys. What do I do? Is it? No, it's not POSH config. What's it? Did I forget what I did? POSH project, lol. Yeah, so I still have the stream demo project from last episode or stream. And you can find the payloads for those in POSH, var POSH, and then the project name payloads. So we're going to be taking a look at the dropper.cs C# pure dropper. Okay, too bad, Rasta. Which is pure C#, which is a pure C# beacon, which you can customize and do whatever you want with. And you can see straight away there's a lot of unobfuscated strings here. And I genuinely think that's the whole point. I'm all for offensive, I don't want to get into this debate, but I'm all for like releasing offensively targeted tools to the public so we both attackers and defenders can learn from it. Nah, so dropper is really misleading. This doesn't actually drop anything on disk. This loads into mem. So I don't know why it's called dropper. It should just be called the beacon. But yeah, this doesn't drop anything specifically to disk. Anyhow, so yeah, so in regards to all the strings and stuff you see, this is 100% intentional by F-Secure Labs. They don't want to do any work for you in terms of making this go around antiviruses. That's up to you. So I'm going to sort of take you down the path on how I would approach that. I started doing some preparations today, and I like got flashback to the NetLoader project straight away, where I actually had like backend infrastructure continually checking the binary for signatures and then alerting me on signatures. And I had like a totally automated flow for patching signatures and stuff. So I started going down that rabbit hole, and I think we'll see. But I think in the end this might end up being like a full-blown obfuscator series, creating C# obfuscators with twist. So we're going to be using Roslyn a lot, basically a package framework for parsing C# code and picking out different structures and stuff. We're going to be looking into that today as well. So we have a lot to do. So first up, I'm going to show you how to take the source code, compile it, and check for signatures using defender check by somebody. I don't want to butcher his name, so I'm going to check the name before I say it. I'm going to copy the source code, hop over to this VM. For this, you need to have real-time protection off, but you can have cloud delivered protection on. Okay, sure, so I'll lower the music a bit. There we go. Right, so I'll just create a new Visual Studio project to drop that source code in. We'll cleverly name that Posh Beacon, if this VM isn't too slow. Let's just call it Posh Beacon. Net Framework 4.5 is fine. Shouldn't really matter that much. I don't think we're accessing any fancy stuff in 4.7 and above. Then we're just gonna copy and replace that, and then we have our beacon. Basically, I could spend like an hour walking through this beacon process. No. Unit testing, like that should be a ban word in my chat. If somebody writes unit testing, they get banned. That should be like a trigger word for my bot. Actually, congratulations, Rasta, you're now a moderator. Where was I? Okay, yeah. So I could spend an hour going through this flow, explaining how it hides itself and encrypts a cookie, sends it to the C2 to verify that the encryption keys are correct on both sides, and then the respond indicates if it should further execute and stuff. I'm not going to. Too much work today. No, I'm gonna leave an exception for you, Rasta. You don't have to ban yourself right now. I'm just gonna leave an exception. A bunch of stuff here. I'm not gonna go into it. I'm just gonna compile this as a release, and then we're going to go fetch that defender check project. So there are multiple variants of this project. Rastamouse has his own called threat check, I believe, and I know somebody else has something called with AMSI. But the original OG for this is Materpreter. I'm guessing it's a funny play on Materpreter, right? Which is basically a binary that takes another binary, splits it into chunks, and feeds it to Windows Defender. And when Windows Defender says, hey, I don't like this chunk, we know what piece of the binary that Defender detected on, and that's how we can find the signatures. This is a really cool project, you should totally check it out. I know Rastamouse has one called Threat Check as well. I'm just going to use the Defender Check one since that's the one I've been using for preparation and stuff, so I don't mess anything up. So I'm just going to clone that project. And there we go, and then I'm going to open it and just compile a binary so I can use it to check stuff. I'm going to build a release for that, and then I'm going to move that release binary over in the same folder as the project I just created. So I have to find that folder, open that. Oh, come on, that's also... We're probably gonna do some debugging, so I'm gonna put in debug. And then I'll open PowerShell window here, I'll build it, and I'll just say, you know what, Defender check, and take a look at this binary for me. And for this to work, real-time protection has to be turned off. But you can't, like, you don't don't kill the Defender service. That has to run, but the real-time protection tag, just turn it off. We'll run it to Defender check, and it will spit out what chunk of the first chunk of data that it finds that is detected by Defender. And as we see it, it found identified end of bad bytes at offset this. The signature name, this doesn't necessarily tell you that much. Sometimes it does. In this case, I mean, maybe this is the start of posh, I don't know. And then it spits out all of this. Now, I've looked at this a couple of times. So this is strings. So let's say, okay, it's a string here called run-exe. If we search for that in the source code, we'll see that's a string. Run-dll, that's a string. It does, right? If you search for EEP 98001, 98, that's a thing, right? So, spoiler alert, what posh does, based on my understanding, is that it pulls a stub and then it replaces a bunch of stuff in that stub before it runs it using regex. That's my understanding. And these regex commands are in plain text. So if I were to create signatures based on this file, I would obviously pull this because this is unlikely to change, and so, unless somebody does something right. So the signatures themselves are effective, but obviously as soon as you don't touch this, like we demonstrated in the previous episode, or if I just go in and change some of this stuff, I might get around the signatures super easy. So from this point, we're sort of getting into obfuscation territory, because obfuscators in C# generally either split functions into multiple functions, creates like bogus flows, obfuscate strings that are hard-coded like this. You know, some obfuscators would use different techniques, separating them maybe, like this. Oh my god, I can't type. Like this, and then maybe base64 encoding this part, reversing this part, stuff like that. And we could definitely go through each of these and do that manually. But that would be sort of labor, right? I don't like to do labor-intensive stuff. I don't know about you guys, but I'm not a huge fan. If I can automate it, I'll probably spend way more time doing that than the actual task, right? Manual labor sucks. Who wants to work for a living? Boo! Right, so what we are going to do is we're going to create our very own source code obfuscator. And the only reason it's a source code obfuscator is that's because I've done that before. I haven't made an actual precompiled C# obfuscator. I haven't taken a C# precompiled binary, parsed it, and then obfuscated it after it's been compiled. I've only obfuscated raw source code. So that's what I'm going to do. And I think it sort of adds an interesting layer. I would imagine it's generally easier to add and subtract actual functions from the code if you can modify the source code instead of the actual binary after it's been compiled. I guess that, I know, it depends on how you approach it. We're gonna make an obfuscator, not a encryptor, or yeah, a crypto. That's the only skid name I have for it. Like, we're not gonna make like a loader or a stub that encrypts it in memory and then unloads it. No, we're gonna actually obfuscate the signatures and get this binary past the Defender. So the way I'm gonna do that, I'm gonna use something called Roslyn. I have no idea if I'm pronouncing that correctly, but I have a link. I'll send it in the chat. Oh my god, I just closed the link. Do I have the link? I think I put it into Notepad+. Yeah, Notepad+, but it saves the day. So I basically googled how to parse C# code in C#, and I found this Roslyn library stuff. And then I searched for how to find strings using Roslyn, and this is like the third or fourth hit. And if you, I'll open that so you can see it on stream here. Damn, this music is good. So the question is like, find all strings to be able to manipulate them. And then I think this guy basically says, based on the accepted answer, this has helped me. And he creates a class called string collector that inherits from C# syntax handler, so he can override the function and check the node types or the syntax node types every time Roslyn parses an element. And then he basically takes that strings, add it to a list, and then I know all the strings that I want to obfuscate. And that was probably too quick, so I'm gonna re-explain that. Don't panic. So I guess we have to make our own obfuscator, right? And we're going to, I don't want to get fired, so I'm gonna start off with the ASCII, right? I've been told that numerous times now. So there's no way, I'm gonna create a project, gonna give it a name, and then I'm gonna create the ASCII art, and then I'm gonna keep my job. So we're gonna call it something cool. Anybody got cool name suggestions? Come on. I need my peeps. Terribly good or terribly bad names will do. Anything. Unicub? No. RosFuscator? MouseFuscator? Cool name for an obfuscator. So I know like dotfuscator is taken. Flangbanger. I love it though. Flangfuscator. This is hard. I mean, RosFuscator was pretty good. I have to admit. I must say. I'm gonna go for RosFuscator just now because I'm lazy. Okay, let's get some cool ASCII art here. That was pretty cool. Welcome to my stream. Today we are looking at ASCII generators. Oh, I like this. I love those like black bars filled. Pretty cool. That was pretty nice. RosFuscator. Oh, that was pretty cool. I have to say, I can barely read what it says though. But it's a pretty cool ASCII art. Okay, I'm gonna go for this. This will do. I won't get fired for using this. So that's sort of bare minimum, right? So it's gonna be a RosFuscator. So how's this again? I can barely read what it says, but it's okay. Oh my god, we got ASCII art, guys. Whoop whoop. Don't know why I used 3, that's Python stuff, we can use 1. Awesome, okay. So what we want to do is that we want to read some input source code. That sounds like a lot of work. I just talked about manual labor. But I should though, note to self. Read some input source code, and then I'm going to pull strings and encrypt them and store them. Save and compile newly obfuscated source code. So obviously later, man, thanks for joining. So obviously just doing string encryption isn't really, I mean, it's obfuscation, but it's bare minimum. But I generally don't think we need anything more than that to be able to get around basic signature detections. In that case, I think it's more the structure of the code, the flow. We might add some bogus logic or something. Right, so we will do source code path. Oh God, I can't type today. Args, the first argument. And then if it's not empty, or if it, let's do this instead. So if it is empty, we'll do missing input source code path. RosFuscator. And then we'll do environment exit. So if that string is no longer empty, and we also have to have another one if that file doesn't exist. So if file, we gotta import that library. If file exists, source code path. So if it doesn't exist, we want to do all that. Awesome, right? And I think the reason we don't want to have those between each other is that if it's empty, it's gonna fail. So actually, this is pretty stupid. I'm a stupid man. So we don't need that check. We can do if args count more than 0. There we go. Hey, Script Monkey, thank you for the follow. I saw your Twitter post. I thought it was a bit weird that you can just remove multiple ones, so thanks for the pro tip. Really appreciate it. Right, so we got some string source sharp source code, or let's call it original source code. Oh, that's sad. There we go. So now we need to identify all the strings in the source code. So let's look at that Stack Overflow post again, and let's implement this string collector class. Simply just gonna smack that bang into the part here. So this, and then it's gonna complain about this. That's fine. Then we're going to need this. This is basically the logic. We don't need return statement. So take this and then put that somewhere here. Awesome. So it's complaining about this. So it's missing a NuGet. So it basically tells me what NuGet is missing, and so that was control dot to get that prompt, and then just select install that package. Just listen to Visual Studio. They're usually correct. Usually. Ah. Okay, let's try the way I did it when I prepared. I just searched for Roslyn. I think it was this one. Yeah. I think you need to install this one before you can install the other one, or it's gonna complain. Huh? What are you complaining about? Okay, so it's complaining about it not containing a reference for that. So do I need like 4.7 maybe then? Let's see. So this one, oh, this is for netcore. We don't want that. We do not want netcore. Well, we could, but generally we don't want netcore. Because yeah, okay. Let's see if this. Do I really need netcore though? Didn't I just create the project? Let me see what this was. I did actually prepare some stuff. So I'm wondering why it won't work. Story of my life though. So please don't tell me this is .NET Core. It's framework 4.5. So did I hit the jackpot in terms of installing NuGet then? Oh, is it because I'm doing it for the solution? Is that a difference? Shouldn't be. I generally don't understand what I'm doing wrong. Let's restart Visual Studio. That usually works. Worst case, I'll just switch to this demo app that I just created earlier. Okay, let's just try to change the target to 4.7.2 or something, because this is weird. I've never seen this before. I literally have another project that has this exact packet installed and is targeting the same framework. Okay, so that worked. You know the thing I said about Visual Studio normally being right? Just forget about that. Straight up wrong. Never listen to Visual Studio. Right, so we're going to parse that source code in. I just need to get all these libraries installed. There we go. So this is an override for the visit literal expression, which takes a bunch of nodes and then looks at the kind, matches it against a string literal expression, which I generally not sure. I mean, I'm guessing Roslyn sort of has a classifies different types of string declarations. So this might be declarations and strings in functions. And then if you have a string as an input parameter to a function, it won't do that, stuff like that, right? So we'll see. Again, today at least, the goal isn't to make a perfect obfuscator. No way we're going to be able to do that. But at least get the basics running. So this is great. And then it creates a new string collector. And for each string item in that string collector, I'm just going to start off by printing them out. So we can see which one there are. Which one there is. So string item. Right? This could actually be a using statement, but oh, sorry. So it's, I gotta look at the example again. It's, yeah, dot underscore strings. There we go. So technically, it would be better to be using here. So, but yeah, doesn't really matter that much. Oh, it doesn't have a disposable, so we can't use it as that. I'll take it back. I'm stupid. There we go. So let's just do a read line at the bottom here so we can see the output before the console closes. And then I'll guess we'll try it, right? So we'll open this. RosFuscator, bin, debug, and we'll open the PowerShell prompt here. And we'll do RosFuscator, and then we'll give it the path to our source code for our beacon, which is this. So copy full path, like that. And it should, theoretically, print out every string in that binary. Or in that source code. Okay, so that's awesome. We see all these. Obviously a bunch of strings. This is awesome. So it more or less works. So there's a couple, okay, so there's a couple of interesting things here. So, obviously we have to add some logic to this. So there's no point of trying to replace empty strings. We could probably add like a minimum length. So strings above a specific length should be replaced and nothing below, just to exclude some, you know, some unnecessary ones. And then we should definitely not obfuscate strings that ends with .dll, because these are actually delegate statements, native DLL imports. And if we can do this, that's a cool trick for obfuscating them, but we can't have any logic in here. So we can't add a convert from base64 in here or something like that. That won't work. These has to be, I think it's called not static, but they have to be like permanent, read only or whatever. But you can do this. That's a cheap way to get around some signature detection that looks for specific DLL functions and imports. Cool. Okay. So we have that. Now let's filter it. So we're going to use link for that, which Rastamouse just had like a beginner-friendly tutorial for. So check that out. So for each element in strings, I guess where x, so the string is nowhere empty, so it's not empty, and x ends with .dll. So if it does not end, and if it's not empty, it does not end with .dll, and let's say x length is more than 3, then those strings are the ones that we will print out. Let's build that and rerun it and see the output we get to make sure those statements worked. And need to wait for the binary to exit. There we go. So now we got specific lengths. We don't get the DLL ones. This is awesome. Cool. So now We're usually, you could just, the easiest way to do this, which we could do, would be to, okay, so say this program picks out this line of code right here, right? Foobar. Then we can take foobar, we can base64 encode it, and then replace the foobar string with convert from base64 string, blah blah yada yada yada, right? So because the white line wouldn't have a string directly, it would have to decode a string on runtime. We could totally do that. And I think we would get past basic signatures with it. But I'm gonna implement encryption instead, because it makes it a lot harder. Because then we can take all the strings and we can randomly encrypt each string with a unique key and then decrypt them on runtime. And when you rerun this obfuscator 2 times, they won't have the same outputs, right? Hey, welcome to the stream. And that would make signatures even harder. So I think we're gonna do that. So we're gonna steal a gist from myself. I have like an XOR brute forcing gist, Flangvik's gists. I think it's public. You should check out my gists. I do have some golden eggs here that I don't always tweet about. So they're better. So this is basically XOR encrypt decrypt. We basically copy this. What is this? Why do I use this? Okay, I don't need that. So we'll copy this and we'll need to add this to both our obfuscator, obviously, but we also need to add it to our beacon. So beacon also has access to that same function. So we'll just smack it in here somewhere. Make it static and smack it in. So let's say here. Yeah, that's basically it. Don't need more than that. We can do public, just to be sure. There we go. And then in our obfuscator, we want to take each. So here we want to, for each string, generate a random key. So a random key that we want to use for XORing. XOR the value. Replace the original value with decrypt logic. This is so badly written, so I mean my grammar, let's not talk about that, that's not nice. So for each string, generate random keep. So we could use the random function we have, but I just like to use quids. So I just do quids, new grid to string. So var random key, and then we do var encrypted base64, or we can do XOR encrypted value. So XOR string would be XOR decrypt encrypt, and then it takes a byte as input and a string as a string, so random key. And then we take the string and we just do encoding, UTF-8 get bytes from a string. So that would be the XOR, that would be the encrypted value. So that would be a byte. Obviously we want this to be a base64 value, so we can do var encrypted string b64. I'm just trying to separate this so it's easier to make sense of. So then we convert that byte array to base64. And then this is the value we replace the original value with, together with some logic. So I'll show you how that would work. So to be able to decrypt this value, I would have to do decrypted. I will have to first take that string and turn it into bytes. No, it will be this, right? So I would have to first base64 decode it and get the bytes from it and then decrypt it. And why is it complaining? Yeah, and this actually turns it into bytes, so I don't need that. So this is the actual logic that we are going to replace the string with. So each string that were static is going to be a decrypting logic, which is really cool. Or not entirely, we would have to do like, this would have to be separated. So let's just, to illustrate this, let's do this. So let's copy this decrypted logic, and then we do this. Then we can basically say like, just to illustrate how this works. So the original value is this string item, and then that gets turned into this piece of logic right here. So if we build this, no, that's the fender check. Wrong binary. Oh, did I close the PowerShell window? Ugh. Why do I do this to myself? You said this is the logic. Okay, random key as well needs to be a variable. So this would be the actual replacements. So instead of, I know this is hard to read at least. So run exe, the string run exe in quotes would be replaced with this without quotes. And that would be the decrypting logic, which is pretty cool. So there's a couple of cases that we have to check. One of them is does this value, the string value that we get, is that a string value in a function, or does it end with semicolons? Maybe you don't have to. Let's just try this and see what happens first. So let's do this. So in the beacon, no, okay, so let's do this. Okay, so sorry, I'm stumbling a bit here. So we did the encrypting logic. So this is going to generate unique logic to decrypt each static string in the source code. Then we want to replace that logic with the original source code. So let's do original source code equals. So let's do what new source code equals original source code, and then we can do new source code equals new source code replace the original string item with the decrypted logic. And then let's write file, write all text. First is the path and second is the data. So let's write it to the same path as the input CS, but with a different name. So let's do the source code path. So file var new path equals file. Yeah, for sure, that's a good point. So you need quotes both here and here. So that's I gotta check this, because I'm not sure if I need to add logic to check if I need double or single quotes, or if I need to escape the double quotes. That depends on how the string is placed in the line from before. So we'll see. I'm just gonna write this part. So file, I think it's, no, sorry, path, get file name without extension. So new file name, and then we're going to take the new path and do source code path, replace the file name with new. Hopefully. There we go. Let's see how that goes. And I need to remove the... I did remove the read line. So that should make a new program, obfuscate program.cs in the posh beacon folder. So let's just check that that works as intended. That created program.ts, which looks like this. And as you can see, we can have the encrypted data here. Now, obviously the problem here, we have double quotes. So this will be a string, this won't be interpreted as code. That's an issue. Need to look into that. Yeah. But other than that, it looks pretty good. Look at this. Looks sweet. So let's just straight up try to fix that the dirty way. Actually, I'm going to add that source code into the project so I can see. I can use the EDE to check, to like show me what's wrong. So if I go to op program, it will show me all the mistakes. And right now, it shouldn't really complain about anything, to be honest. So let's just try to identify or expected. Yeah, so it complains about this. Int x. Right, so this was, what was 426. I'm just gonna check the edge cases here to make sure if we need to add any more logic. 426, 426. So that was in. What did it? Okay, so here's a nice conflict. Some of the strings that we found are also variable names. Hey, what's up, Rosho? But this will sort of sort itself when we add the double quotes in the RosFuscator. So let's do that. So in the replace value here, we actually want to replace them with the quotes. There we go. So let's rerun that, compile it, and rerun. And then if I go back into op, this will be, there we go. Now it's not complaining. So now I need to add the double quotes that you warned me about. Awesome. So I'll basically do like this. And then I'll escape them. There we go. Awesome. So now it's complaining about not finding some functions. So it can't find XOR encrypt decrypt. Why is that? Okay, so I'm missing a semicolon at the end of every one of them. So I'm missing one of these. So yeah, that's about right. So let's rebuild that and rerun. Oh, music stopped. Gotta fix it. Give me a second. I'm really impressed with the Monster Cat music, to be honest. It's pretty good. Pretty good. Some of it is old. I definitely need to create a playlist, but it's pretty good. So this is the new logic, and I mean it has everything correct. This call is between. So it already has one? Wait, there's two of them? Why is there two of them? What? I've fucked up some class parameters or something. Okay, so it's because of the original one. So we can actually unload that. So that would be delete wouldn't. I'm pretty sure delete doesn't actually delete it. Yeah, I am pretty sure delete doesn't actually delete it. So I'm gonna delete it. It actually got deleted. Fuck. No. Fuck. Let me restore that real quick. Then I got to show you Dave though. That's pretty cool. Okay, so I guess that was a fix because now it isn't in the project anymore, so that's good. So now it's complaining about convert from base64. It gets a string, that's fine. This gets a byte, that's happy. This gets a string. So this is the complainer right now. So this. Rebuild, re-obfuscate, and we are good. So now, what's the issue here now? Cannot implicitly convert byte to string. Yeah, so that's right. Now we need the get bytes or whatever. So we need the because this is bytes, right? So now we need the encoding. UTF-8 get a string from those bytes. So we'll add that to our logic. Rebuild and rerun the obfuscator. There we go. What's the issue now? The expression begin as under charge must be constant. Yeah, so this is also a failsafe that we need to add. So we obviously don't want to obfuscate the string we use in our random function. So let me pull that original program up real quick. I will check that random. So we don't want, this is a whitelist, so we need to whitelist that. So the way I'm going to do that then is, oops, wrong. So in the logic here, where is the if here? So this is the where. So yeah, this is dirty, but I'm gonna do it. If x equals, it's so dirty, but it's fine. It's fine. Oh, now it only complains about, wait, what? Why, wait, didn't I just fix this? Pretty sure I just fixed this. So the string wasn't equal? Oh, sorry, it's not equal. Now it only obfuscated that part, that made sense. There we go. And let's see what the issue is now. Yeah, so there's another random string function that we need to that is also a const char. So now, right, so the problem now is that we're adding static logic to our obfuscator so it works specifically with posh. We would want to somehow include strings that are declared as constants. So I'm gonna give that a shot, and if I can't do that smoothly, I'm gonna postpone that to another stream. But I'm wondering what sort of information we can get from this node, right? So node token text. What is that? Let's try that. RosFuscator. Okay, so that obviously isn't gonna work. We need to hard code an argument for that to work. That's fine though, we can do that. Oh my god. I'm such a screw up sometimes. So we need to do args, just like a dirty way to get around this. Oh. Thanks for the follow, Prue. Index outside of bounds array. How can it be? I literally just assigned it. Args, new string. Hey, my Frenchman, what's up? Shelf, whatever. Okay, so that text value. Okay, so that's pretty neat. So that text value actually includes the quotes. That could be useful. That could be super useful. Let's look at the node if it says anything about being a constant or something. Is missing, has trivial, parent. Let's look at the parent text. Right. That doesn't give us much. Okay, so I'll let me do this. So so this is just to get a breakpoint at the node that I know I want to exclude, so I can look at the properties for the node and check, okay, is there some way I can check if this node is a constant. So I hit the node. Let's see if there's some way for me to check if it's a constant. Has leading, is missing, kind of text, string literal expression, parent, equals value clause. Can I check if that parent is a constant maybe? Equals syntax equals token equals verbal clause. Options. Okay, so I'm gonna Google off screen. I'm gonna Google Roslyn. Is var a constant? So we're basically making a source code C# obfuscator to patch some signatures in a C2 framework called Posh. Because I thought it would be easier. Huh, it isn't. So there is definitely a way to do it. I see people getting the options. So I think there gotta be some information from this node. So span doesn't tell me anything. Parent trivia doesn't tell me anything. The parent tells me what kind the parent is. What's the parent for that again? The parent for that is a char. What's the parent for that again? Huh. And the parent for that contains... where's token here? So I get that, but so I think we need to look at two parents up token value. So let's node parent token to full string. So let's see what this is. So that almost worked actually. This is so hacky. I fucking love it. Okay, so there's our const. This is so hacky. I love it. I mean, there's... yeah, sure. Oh, this is so hacky. This is I have to find a better solution for this, but I'm gonna try. So try. I'm gonna try then the try catch statement. So I'm gonna try to, if this stuff here contains const, then I definitely do not want to do anything. So if it does not if it does, how would this be? So this and then continue, right? Continue. Or would it be break? Or would it just be return? This is so hacky. If it works, it works. Well, it works. It freaking works. Ruffle. Well, it fucking works. Okay. So it does work, and I can actually now compile the beacon, and it should technically just work. No, so as you see, there's a lot of stuff that isn't replaced. So why is that? So I definitely did something wrong here. So I think the return statement actually stops it. So is it skip? I guess. I was pretty sure it would just return. Oh, wow. Okay, so I forgot this if statement here. Wow. Sorry. My bad. There we go. So that worked. I see some red. It's not a lot though. Okay, so this is also an issue. So if the string starts with this thing, how am I gonna handle that? So I could just when I do replace, I could just do it like twice. Because if this doesn't exist, then it's not gonna do anything. If it does exist, then this isn't going to exist. So, I mean, Hacky is my middle name at this point. Why not? Yeah, that worked. Lol. Hey, it compiles! Whoop whoop! It freaking compiles, people. Wow. Okay, that's cool. I have no idea if it will work though, but it compiles, and that's usually a good sign. So this is pretty cool. So every string in this beacon now is XOR encrypted with a unique key. So there's technically no way to signature this, because every time I run the obfuscator, the string is going to get a new key, and the output value I'm trying to decrypt is going to be different, and that's why there's no like match for it. So I'm not too worried about that. So the string detection here should be fine. So I guess it compiled, it's in debug, we can run the Fender check against it now. I mean, oh my god. Yeah, that's a wrap, guys. So apparently the Fender just doesn't care about anything else than strings. So that's awesome. What the fuck is this? Yeah. So that's yeah, as you say, Revshol, that's apparently only a surprise for me. I genuinely thought I would have to do something with the flow at least. But apparently I don't have to, and that's great. I mean, I'm not gonna complain. This is hashtag easy, right? So let's try to. So I'm going to remove the ends with DLL, and I'm going to add the check for DLL import instead, because that's what I'm trying to get rid of. So like, if the parent contains const, okay, so let's do public static bad strings. Oh my god, I'm so bad at the keyboard today, sorry. So we're going to create new this, and then if this contains, no, that's going to be wrong. So there's a couple of ways we can do this. I'm not gonna do it a very cheesy way, so found where. So for each string in this string array, if that string is in the full path for node parent, then it's going to be more than 0, and then it's going to return. So this should work. So we don't want to do this, but we want to do DLL import. Hey, I didn't break anything, I think. No, I didn't. Awesome. So just to show, so look at these strings, right? You see these? Let me rerun the obfuscator, and then you see they changed, right? So this is KCH, rerun. Now it's KHE, rerun, EHX, right? So they change every time, so it's going to be real hard to get signatures from it. I feel like this could be a for loop. I'm not going to do that. Well, I mean, it works. Rocky, I mean, yeah, it works. Yeah. Probably not going to work on every beacon you play with, but it works. So I'm going to add this in the source code here. So I think that was too easy. That was generally too easy, but it's great as well because then the episodes don't get too long. So I think in the next step, next stream, I'm going to add logic to automatically add these functions to source code so that you don't have to manually add them. And then I would really like to add obfuscation of function names. That would be awesome. And obfuscation on variable names. I think that's gonna be difficult, but we'll try. And I mean, if I can make this less janky, that would also be great. But I think we have to try. I think we have to. I mean, it freaking works, right? So I think we have to try the beacon and check if it calls back and everything. So this is where the beacon is in release. If I try to scan it with Microsoft Defender, it goes. Wait, it found a threat? What? That's probably an old threat. See details. Yeah, yeah, so that's the one. Oh yeah, this is the release one. We're doing it against the debug one, right? Yeah, we are. So I was worried there for a second. So this is the one that we're testing against. And if I scan that, it should be fine. Yeah, it's fine. So it's still there. So let's fire up the Porsche C2 server and check if it works. That's sort of a thing we need to do, I feel. So Porsche server, call it. There we go. Yeah, so the kill date already expired for this. So I'm actually just going to remove that check from the source code instead of recompiling. So where is that check? Date time parse. So this is probably it. So I can just remove that bad if. There we go. Debug, push beacon, running. And we got a connection. It fucking still works. That's awesome. So push you Melvin. So there we have our undetected beacon running fine. Let's try to run the command on it. Who am I? Let's try system information maybe. Get user info, get computer info. Let's see if it works. Or if it died. So it died. Why did it die? It didn't get detected. Is it still running? Might be my handsomely bad fix. Yeah, so might be that. It does compile though. That's one thing, right? Yeah, so it probably kills it because we're past the date. That's probably it. You know what? I'm not gonna test that now. I am confident that this works. I'm guessing it's just because the expiration time. There's probably logic on the Porsche C2 team server side that checks the date and then kills the implant if it's exceeding the date. So there's two checks on both on the beacon and on the server side. So I'm not going to generate a new beacon and do that stuff now. So we basically made a nifty little C# obfuscator with a bunch, probably like a metric ton of edge cases. But it works for Porsche, so that's something. So yeah, I'll guess I'll push this. So I think that's gonna be it for today's stream. I like to keep it short. I think this sort of stuff is pretty brain intensive. So I mean, if it's not like watching people play games. So I think it's better to do like an hour and then at least you watch the whole thing instead of doing 3 hours and then you have to jump off. So I mean, I really appreciate you guys joining in. It means a lot. It's super fun. I still have a lot of energy to do these streams every Sunday. So I mean, check out my YouTube channel. So all the videos are being recorded and will be uploaded to the YouTube channel, so you can check them later if you didn't have time or if you want to go back and rewatch something. If you have any suggestions for topics, hit me up on Twitter, or I guess yeah, Twitter mainly. DM me or retweet me at Twitter. I'm open for suggestions. I don't have like a long list of things that I need. I make this stuff up a couple of days before I stream. So I'm like, if you have suggestions for stuff that you want to see, be sure to let me know. So yeah, that's basically it. Thank you so much for tuning in. Any questions or anything, Twitter or just pop it in chat. I think it's super fun to do this sort of stuff. So I'm gonna wrap it up then. Thank you so much for joining in. See you next Sunday. Have a great week. Work week, right? Monday tomorrow. Get all energized. Enjoy your week. Thank you guys.